Right, okay, on to the next algorithm, the binary search. Now, binary search, a super quick way of searching a sequential list. Okay, again, the prerequisite for this is that the items we're searching are in order. Does not work with a serial list of data. Okay, unfortunately, you have to use your serial search methods on that. You could use sequential search on a sequential list, but that would involve examining every item up to the one that you're looking for, or to the one bigger than the one you're looking for, which might not be many. Depends how big your list is. Okay, if you've only got a very small list, you can probably get away with using a sequential search. But when you're talking about thousands of data items, a sequential search is never going to, on balance, beat binary search. Okay, because the way that binary search works, and the reason it's called binary search, is that you're splitting the list in half each time. So every time you examine a number, you're reducing the size of the data items that you're looking at by half. So if you start off with 1,000, after looking at one number in the list, you'll only have to look at another 500, roughly. Is the process it works using. Okay, so here's a little algorithm. I've got 10 numbers stored in an array. So that will allow us to individually access the data at any particular location, any element position in this array. So let's just number these up. Okay, so 10 items. Now, the main controlling part of this algorithm is this while, which has got a double condition on it that's saying, right, okay, I'm going to have a couple of pointers, a left pointer and right pointer. Okay, and those values, so I'm just going to keep track of those. Left, right, and that while loop is saying, right, okay, as long as the left pointer is to the left of the right pointer, and the second part says, well, the one that we're looking at, the middle item, which is what we always look at in the binary search, if that isn't the item we're looking for, when we keep going. So while we haven't exhausted the list and we haven't found the item we're looking for, we're going to keep going, and that's what that while loop's essentially doing. There's not much going on in there, to be honest. Okay, so let's keep track of left, right, middle. I'm just going to put as an M because I can't be bothered to write middle. Alright, so we start off with left is 1, right is 10. Right, now when we calculate the middle, if we add these two together, we get 11 divided by 5, that's 5.5. Now you can't access element 5.5, so we have to do integer division. Okay, so we're going to set middle to 5. Now the while loop, the first condition is true, so left is less than right, and let's say we're looking for the number 47. Let's go for 47. Now, scratch that, let's go for 33. Okay, so is where middle's pointing, which is, I'm going to put in square brackets, it's going to do that to mean the item at middle. So currently that is 19. That is not the one we're looking for, so we're going to have to go into the loop. And we've got this if, so we're saying, like, is the item we're looking for, 33, is that less than the value at middle? Now the value at middle is 19, so that's not true. So what we're going to do is we're going to move the left pointer and discard the left hand part of the list. So there is no point in looking at any of these, because the number we want is bigger than 19, so it's obviously going to be bigger than all those because they're in sequence. So the left pointer is going to move to middle plus 1. Middle is 5, so left becomes 6. So we then need to recalculate where the middle is. So 6 plus 10 is 16, so middle's going to be 8. The item at 8 is 25, so let's just put that down. Okay, and we've reached the end of the loop, so let's move back up to the while. So left is still less than right, 6 is less than 10. Right, what about the item at middle? No, 33 is not 25, so we're going to go into the loop again. So we're going to say, okay then, so we haven't found which part of the list are we discarding. So the item we're looking for, 33, is that less than the item at middle? No, it's not. So we are going to discard all the items to the left. So we don't need to look at any of these. Okay, because the item we want, we've already determined, is bigger than 25. So let's scratch out 19. So we looked at 19, we looked at 25. So we're going to say left, that's this bit, is middle plus 1. So left is 6 currently, middle is 8, so 8 plus 1 is 9. So the left is going to become 9. Okay, so the item at 9, we're going to work out where the middle is now. So we've got 9 and 10. So 9 plus 10 is 19, divided by 2. I'm just doing truncation. So middle's going to now be 9. The item at that position is 30. So let's make a note of that. Go back up. Left is still less than right. 9 is less than 10. Right, the item we're looking for is 33. Is that the same as the item at middle? No. Okay, so we're going to go into the loop. So let's have a look. Is 33, the item, less than the item at middle? No, it's not. So we've looked at that one. So we're going to end up again going left. So we say, oh, left is equal to middle plus 1. Now middle is 9. So middle plus 1 is going to make that 10. Okay. Right, 10 is 35. So when we do, oops, sorry, missed a step. When we calculate the middle this time, it's going to be 10 plus 10 divided by 2, which is actually going to be 10. Oh, why does it keep doing that? Let's go back on the drawing tool. So that's 10. Oh, let me just delete that and draw a 10. That's better. Okay, the item at 10 is 35, but you'll see that the while loop stops us even bothering to test. Because when we go back up to the while loop now, we say is left less than right. 10 is not less than 10. So this part of this condition is false. We've got an AND, but there's no point in doing any more tests, because if one part of an AND is false, the whole lot's going to be false. So we don't even check that. So we said, right, well, this condition's true. We've basically got to the last item that we're going to look at. So let's cross that out in a sec. So we're going to drop out of the loop, and we come to here. We say, right, okay, at middle, which is 10, is that the item we want? No, it's not. Okay, so we're going to output item doesn't exist. Okay, now you can see that we actually examined 1, 2, 3, 4 things that we crossed out, 4 items out of 10. Okay, little bit of work involved. It would have been quicker to do a sequential search, to be honest, but if we'd have extended this list a little bit more, which obviously I'm not going to do because that would take me ages doing this, but if we'd have extended it a little bit more, we'd have seen the benefit. If you do about 1 million data items, you tend to have to look at about 22, 23, something like that, off the top of my head, in order to determine whether something doesn't exist or whether you've found the item. So it's an ultra fast search method. Okay, and that is in essence all there is to it. So it is just looking at the middle. Is that the one we want? If it's smaller than the one we're looking for, then we can discard the left. If it was bigger than the one we're looking for, we'd discard the right hand side of the list. Okay, but you're always going for the middle, so it's like optimal each time. Okay.